Today we're continuing our graphing of sine and cosine, so it's the same process as what we saw in the previous video, and we're just adding a few details here. So we'll use example 1 and 2 to ask this question. What do you think the horizontal shift will be? All right, we've graphed with transformations before, and we've used them with parabolas and other kinds of parent functions, and we typically look at this value here to determine which way and how far it's going. All right, so you might look at this and say, okay, we got to change the signs. We know it's going to go to the left. But how far to the left will it go? Will it go pi to the u to the left, pi over 2 to the left, or something else? You know, here's example 2. That's a negative pi over 4, so we would change that to a positive pi over 4. So how far will that go? Will that go pi over 4 to the right? Will this go pi over 2 to the left? Let's see what happens here. So we'll go through the whole process of graphing, and then we'll come back and answer this question. So A is 1, B is 2, C is the positive, right? But we always change the sign, so it's a negative pi over 2. And then D is 0. So there's no vertical movement at all. So our amplitude is just 1. The period, we always take 2 pi divided by the B, so that leaves us with pi. We take that result and divide it into 4 equal parts. So that's our scale. Counting by pi over 4. A few of these negative values as well, negative pi over 4, negative pi over 2. We can add more if we need. Okay. When we're finding the starting and the stopping values, we're taking everything that's in the parentheses. So notice this includes both the b and the c together. So it's the 2x plus pi over 2. And we set that equal to 0 because that's where it's going to start. Subtract pi over 2 from both sides. We have a negative pi over 2. And then here, that's a pi over 2, there it is. And then we'd divide away the 2, so that means we have negative pi over 4. All right, for the stop, again, we take everything in the parentheses. 2x plus pi over 2, we set that equal to 2 pi. Subtract pi over 2 from both sides. And notice that we have an uncommon denominator here, so we have to create a common denominator of 2. So this would be 4. Let me try to fix my own mistake there, 2 pi. So that'll be 4 pi over 2 minus 1 pi over 2. That gives us 3 pi over 2, right? So 2x equals 3 halves pi, and then divide away the 2. So x is 3/4 pi. That's where we will stop. And as there's no vertical shift, our midline is at 0. Just to give myself a little bit more breathing room here, just because we have a very small amplitude, I'm going to use every other grid line here for my scale. So it'll just be a little easier to see what we've got. So the midline is here at 0. With the amplitude now, my maximum point is at +1 and my minimum point here at -1. So that's the band through which we will see our curve. We're going to start at negative pi over 4, which is here, and stop at 3/4 pi, which is here. So that's the window. That's the box where we will see exactly one cycle occur. There's no reflection here, so the cosine is that V-shaped graph. So first point is here in that top left corner. We jump to 0 on the midline, and we jump to pi over 4 at the minimum, and then back up again. All right, so there's our single cycle. Again, we could draw 2 periods. If the problem asked us to, we would just copy and duplicate that either on the right or on the left. We could make that work. But here it is 1. So maximum point is at 1, minimum is at -1. So the question is, what is the horizontal shift? Notice that what we're looking at here is both the value of b and c together, working our way to solving for where we start, right? So where we start is not at 0, so we've obviously shifted. How far did we shift? Pi over 4. So in other words, it's not the pi over 2 that we saw printed in the equation. So it's not just the c, it's both b and c together that influence how far it moves. So where we start is the same as the horizontal shift, or horizontal translation. I have to be a little bit more careful in how I say that, because some of the graphs that we're going to be doing when we get to tangents and cotangents, for example, they don't always start at 0. So to be more accurate, we would say you calculate your horizontal shift by taking everything that's in the parentheses and you set it equal to 0. You also find the starting point by taking everything in parentheses and setting that equal to wherever your parent function normally starts. So yes, cosine does start at 0, so that's why we're using 0. So that doesn't mean we have to calculate it twice. We can kind of piggyback the horizontal shift on top of the calculation for the starting value. All right, so here's graph number 2. Again, we're kind of also talking about what is this horizontal shift. So it'll be a positive to the right. Now, in this case, my value of b is just 1, right? So that means we don't have to worry about that. It is exactly what we see here in the value of c. So it'll be to the right of pi over 4. So there's the a, there's the b, the c, and the d. All right? So value of c is positive pi over 4. That tells us the direction that we're shifting. Okay, amplitude then is 2. Period is 2 pi divided by 1, so of course that stays the same. We take that result of 2 pi divided by 4 to get our scale. So pi over 2 is what we have here. So pi over 2, pi, 3 halves pi, 2 pi. Let's see, if we go one more, that would give us 5 halves pi. In the negative direction, we'd have a negative pi over 2, a negative pi, and we'll add more if we need. Where do we start? All right, take everything in the parentheses, x minus pi over 4. And sine normally starts at 0, so we set this equal to 0 as well. So we're going to start at pi over 4. And we just learned that's the horizontal shift, right? So we're shifting to the right, pi over 4. Where do we stop? We set this equal to 2 pi and solve. Again, notice that we have an uncommon denominator here as we're adding pi over 4 to the 2 pi. So we need to create a common denominator. So we have 8/4 pi plus 1/4 pi. That'll give us 9/4 pi. So the issue with this example, the reason why we have this example in the first place, is because of these details right here. These values don't coincide, right? The scale is counting by half of a pi. We've already labeled that. And normally, up to this point, when we've had horizontal shifts, the shift has taken us to that scale value. So in the typical example, we would have shifted to the right pi over 2, but we're not. We're shifting something else. So this is not a number on the scale, right? So we have to figure out where is pi over 4 compared to what we have identified as our scale, and let's find that. So in other words, we're not doing a shift to pi over 2, we're doing a shift to this empty interval between 0 and pi over 2. There's my pi over 4. That's where we're going to start. So in other words, we're shifting to the right half of an interval. So we'll come back and add more detail in a moment. The midline here is positive 3. So on my scale, I'll go by ones. Here's my midline at 3. The amplitude is 2, so 2 above is 5, and 2 below is 1. Typically, if I didn't have a shift at all, my sine curve would start at the midline. We'd jump to that first interval at pi over 2 and go up to the maximum. We'd jump to the next interval at pi, back to the midline. Jump to the next interval at 3 halves pi to down here, and then jump to 2 pi. Right, so this is not the final answer, but this is what the sine curve would look like if we had no shift at all. So it's helpful to figure that out first, because then when we do our horizontal shift of half of an interval, what we'll do is we'll just take each of those 5 critical values and slide them over half of an interval. So this first point is here at pi over 4. The maximum point is slid half of an interval to the right. The third point, the fourth point, the fifth point. So where that fifth point ends up, that is the stopping value that we calculated at 9/4 pi. And here's the final result. Right, so it turns out this is our box. Right? There's the starting, there's the stopping, there's the box that we have right there. So our minimum is at 1 and the maximum is at y equals 5. All right, so compare these two problems here. Just look at the horizontal shift, right? So in example 1, when we have a value of both b and c together, they work together to create what that horizontal shift is. So it's not just the c by itself. Here in example 2, again, we're using the b and the c together. It's just that the b is a value of 1, right? So when I say take everything in the parentheses and set it equal to this something, well, that includes both the b and the c. So that's why both the b and the c are working together to determine what that horizontal shift happens to be. Here's our third and final example. We want to take a look at this one. This will be with a reflection, so a is a -5. B, be careful, it's not the 2 in the denominator. You want to think of it as a 1/2. You want it to be a constant multiplier in front of the input. So think of it as 1/2 times x. C is -pi, and then D is -4. So when we have this amplitude, we always want the positive value, right? So it's going to be an amplitude of +5, but I don't want to forget to reflect. So I usually just give myself a little bit of a note to say, hey, don't forget, you need to flip this upside down. Of course, I didn't even spell that right. We want to reflect that upside down once we've graphed our 5 key points. Right. Period of 2 pi divided by half is going to be 4 pi because we multiply by the reciprocal. So that means our scale is going to be pi. To find the start, again, take everything in the parentheses and set that equal to 0 because that's where cosine normally starts. Subtract pi from both sides and then multiply both sides by 2. So -2 pi is where we start, and then where we stop, again, take everything in the parentheses, set that equal to 2 pi. Subtract pi from both sides and then multiply by 2. Right, so if we're starting at -2 pi and we're stopping at +2 pi, that is an interval of 4 pi altogether, and that agrees with the period that we have found here. So with the jump, the scale being pi, let's count off our tick marks here. But we want to start at -2 pi, so we need some of these as well. All right, the midline is at -4, yes. Now, because we're going down 4, and then we have an amplitude of 5 beyond that, let's count by 2s on each of these grid lines so that we can fit everything in. So what that means for us here with the midline at -4 and the amplitude of 5 on top of that, we're going to have a maximum at +1. So we're right between the grid lines and a minimum at -9. Again, between the grid lines, we're starting at -2 pi. Stopping at +2 pi, so there's the box that we're using. Now this is cosine, and remember cosine typically has this V-shaped pattern. But don't forget, we have to reflect it upside down. So the maximum point is now at a minimum. And the minimum is now at the maximum. And there we go.